Hello, everyone. Hopefully, you guys can hear me now. We had a little mix-up. I didn't realize that this was on Zoom, so I jumped onto Google Meet and was waiting for everyone to join, and I didn't see anybody. So looks like we're at 32 participants here, and that's great to see. And I'm really happy to present some information for you guys. I'm going to start sharing the screen here, um, and I'll get the presentation booted up, and we can begin going through it. All right, so everyone can see the screen here, hopefully. Just give me a quick confirmation in the chat window or wherever we might have. Um, there's a Q&A button here through Zoom, so you feel free to put your questions there. Danielle will note those down, and then we'll have a QA session at the end here. Danielle, can you just send me a confirmation that you can see the presentation screen? Great, excellent. All right, let's fire this up and begin here. So today's well, first, hello everyone, and thank you for attending. Uh, this is Think Ahead Tips for Propeller Inspection with 3D Scanners. I'm Adam Kaplan. I'm the CTO of TrueProp Software, and I'd like to really welcome everyone to another TrueProp webinar. It's been about a year since we did a webinar. We'll try and get a few more of these, and I really enjoy presenting. So if there's topics that you want to know more about, please reach out to us. Let us know what you think our next webinar should cover. And as I mentioned, note down any questions in the chat. We'll have a Q&A session at the end here. So I wanted to just outline the presentation before we begin. I think today we've got some really useful content for you. And I hope everyone can walk away learning something new that they can apply to their work. So first, we're going to cover, why should you consider 3D scanning for marine propellers? We'll talk about kind of how this unique approach has several advantages for propeller repair and service. It's also a great engineering tool, and we'll jump into that as well. We'll see a couple examples from recent jobs that we've done. And before diving into the meat of the presentation, which is going to be the tips and strategies for 3D scanning marine propellers. And during this presentation, we'll show some software tools that can really leverage 3D scan data. So let's begin. This is a slide we presented before, but the traditional approach when we want to get some data about the propeller's condition or geometry, it usually requires removing the propeller from the ship and sending it to a specialist. And obviously, for large propellers, propeller removal alone, it's quite a task. It requires crews, lifts, special tools, and after removal, the propeller has to be rigged and transported to a specialist or an engineering company. And there's of course turnaround before the prop is sent back, at which point the rigging and the reinstallation can commence again. And in some cases, the prop may have been in suitable condition. For instance, if we were just capturing the data to make a new propeller, we're not even reworking it, but it still has to be removed so that we can go and, scan it with a probe-based system and capture chord lengths and pitch and all that. And if it was for repair, we're not sure if there's even any damage or not, but we're still removing it just to check it, right? So can you imagine the time and cost savings if we could just inspect the propeller without having to remove it from the ship? It'd be pretty significant. And so now we kind of offer a solution that can do that. It allows propellers to be inspected anywhere. And what we're doing is we're leveraging commercial metrology equipment, such as handheld blue light scanners. And that gives us a new versatile way to inspect the propeller without having to send it away to a specialist. So like in a scenario like a dry docking, we can check the propeller's condition without having to remove it at all. And in the case where a propeller needs to be replaced, we can capture the current geometry for building that replacement again by just visiting the ship itself. Uh, the 3D scanners today are very accurate. They're very easy to use, and the accuracy is less than a millimeter. It's on the order of thousandths of an inch, uh, and that's usually better than traditional probe-based tools. There's no deflection in the drop rods or bearings that wear out. It's an optical system, and very versatile. And so you can capture the propeller in almost any environment, indoors, outdoors, sunlight, cloudy day. The scanners are versatile to pick up the geometry. And obviously, this bypasses all that labor for removing and rigging and transporting. Um, so you can also get started inspecting propellers for your projects uh, with just a laser scanner and technical software. So it's kind of helpful in lowering some of the barriers here for the industry. And we offer a few different packages depending on basically the size of the propellers you're looking to inspect. Speaking of size, here we can see a large propeller being scanned. This is a project that we did last fall. We've been kind of putting together case study information on it, so you'll see a bunch of stuff on it soon. It's a 14-foot propeller, originally the primary propeller on a submarine that's now been mothballed and kind of actually is a museum piece. So you can see the size of the propeller over there on the left and buildings behind it. It's pretty cool. But I want to just point out that this technology can be used for really large propellers. 160 inches is kind of the limit for this particular scanner I'm using right here. But it's also great for controllable pitch propellers, propellers with overlapping blades, and you know, our TrueProp software takes that 3D scan data that's captured and it extracts the data that's needed to check tolerances across these blades. Uh, and then we can produce a report that documents the measurements, tolerances, and any areas that are out of spec for that desired class rating, and all without removing the prop. Now, these 3D scanners generally just output an STL mesh file, and through a bunch of experience, we've come to recommend blue light laser scanners, um, and we'll talk about some of the things that you need for blue light laser scanners, like the markers and things like that. Okay, so also, these commercial blue light scanners have become very affordable, and they are very fast and very accurate. They can be used for lots of other projects, from checking running gear and shafts to mapping an engine room, exhaust piping and engine mount points, down angles for the through hull fittings. It's a general purpose engineering tool that we are applying to propellers. So it's very easy to take the scanner and use it for other projects. Again, there's boat builders using this to scan hulls, and yacht builders using it to design interiors and set up engine compartments and so on. It's phenomenal for capturing struts and rudders, and it can check shaft alignment and straightness as well. So there's really a lot of advantages here beyond propellers. So, it's great. We can get a 3D scanner, we can capture geometry of the propeller in the computer. But what can we do with that data? I mean, it's without post processing and tools to kind of digest that data, it's just a surface or a cloud of points randomly positioned in space. And that alone doesn't tell us anything about the propeller, the geometry or the condition. We can maybe calculate like some areas or volumes or weights, but you know you could make a duplicate of the propeller, but each blade's going to have some variation as well. So why remake a propeller that's imperfect? So at the top here, the top middle graphic that you see there, this is what we call a heat map overlay. And it's kind of very common for traditional metrology inspection. If people are inspecting parts or doing dimensional analysis on things besides propellers, this is kind of what they use. Um, for us, it's not the most helpful because it doesn't tell us anything about geometry, pitch, chord lengths. Um, and the other thing is that it requires a design CAD model. You have to have something to compare your scan to. And we don't have design CAD models for propellers, generally speaking. Uh, so kind of that brings us to how do we make something useful out of this data? And that really depends on your objective. Um, you want some software to post process this scan data into something useful. If your objective is propeller inspection and checking for damage and checking if it's within tolerances of an ISO 484 class, S123, uh, TrueProp is the way to go. TrueProp will let you take that data, it will extract pitch and uh, the ISO inspection data from that mesh file, and it will prepare this report that gives you the diagnostic information you can pass on to your customer. If your objective is to recreate this propeller for replacing it or for manufacture or reverse engineering, whatever you have to do, if you're looking to get a 3D CAD model or a 2D uh, drawing of the propeller, you can use a different set of software from HydroComp PropCad, which allows you to kind of interrogate the geometry and then represent it in a parametric tool that allows you to smooth things out, bumps and bruises and things like that. It also prepares the drawings, the table of offsets, things that you need to actually manufacture a propeller. So again, depending on your objective, these would be like kind of two pipes you might go through. And there might be some others, if you need performance data or things like that, simulation data. But these are the two I'm kind of going to cover today. So let's just talk quickly about TrueProp. Uh, we were formally established in 2017, and we create software tools and integrated machines to inspect propellers. And our goal is to provide customers with the highest quality analysis software, repair guidance, and professional reports so that they can provide ship owners and operators with the best performing propellers possible. And traditionally, propeller inspection has been performed by, propeller specialists who have the equipment to handle, measure, and refurbish propellers. That's definitely our primary market is the repair specialists, the repair shops all around the globe here. But this 3D scanning technology really allows us to be more accessible to shipyards, boat builders, dry docks. They can now incorporate 3D scanning as part of their QA process, and helps them take a little bit of ownership on this. Uh, and the propellers are the important part of the propulsion system. So, um, the more frequent they can examine it, and the easier it is to examine, um, the better we can have a better operating fleet. Now, um, HydroComp predates TrueProp by many decades, and HydroComp and TrueProp staff, there's a ton of overlap. And I still work for HydroComp on the propeller tools as well. Um, HydroComp is renowned in the propeller industry for software tools for speed prediction, vessel powering, and propeller sizing. And they offer a few specific propeller tools, including PropCAD for propeller design and Prop Elements, which is more of a wake adapted propeller optimization tool. And these two codes can handle propeller geometry. So that means that we can use the 3D scanner in conjunction with these tools to do some more detailed engineering, like non-inspection projects, but design, manufacturing, performance analysis, that type of thing. So now we're going to get into those tips that I wanted to share with everybody. Um, and let's talk about kind of uh, approaching a project and what we might have to do. The first thing, is the surface of the prop. Um, you know, Actually, a shiny surface is harder to scan than a dull matte surface or even a really dirty surface. So you don't want to spend the time to clean and polish the prop. Knock off like big barnacles and things like that are actually going to affect the surface measurements. But if it's highly polished, what happens is the laser like reflects off the surface, and then the scanner captures the reflections, gets a little, oops, sorry about that, gets a little noisy and confused. So if you have like a really high polish, like a stainless steel cleaver propeller, we recommend using basically a scan spray. And they make this spray that you spray on. It's there for an hour, and then it kind of disappears, evaporates. So that's super useful as far as like you reducing your cleanup time. You spray it and then forget it, right? It just you can blow it off with an air hose after it just kind of disappears. So this vanishing spray, it's great. And depending on your scanner, not all scanners are the same. The higher end scanners, the ones that we recommend, handle highly polished surfaces and have compensation for reflection. But there's some kind of cheap entry level scanners in the $1,500 to say $8,000 range that they don't work as well without the scan spray. So depending on the scanner you get, you get a cheaper scanner, you got to do a little more surface prep. But generally dirty, not reflective. Um, and now let's talk about markers, which a lot of people are initially a bit worried about the time it takes to put the markers on. Totally get it. But it's really not that bad at all. Uh, we use markers because the scanner's an optical system, and when you have repeating geometry, like think of the rim on a car, where you have all these spokes or whatever, the scanner's looking at basically the geometry and mapping it. And if two things are very, very similar, it can get confused as to which spoke is which on a wheel. Same thing with the propeller, so it can get confused on which blade is which. These markers help one distinguish each blade uniquely. So even if you could do markerless tracking, sometimes that's helpful, as far as just you don't need that many markers, but maybe okay, you need just a few to make sure each blade is unique. Now, when you're scanning and you're using tracking markers, every image like that you capture, every time you wave the scanner around, it's got to see at least four of these little reflective dots. So there's, depending on your field of view, that determines how much you have to space it. Typically for like the scanner that this gentleman's using here, I think the dots can be like 4 to 6 inches apart based on the width of the laser, so that captures four of them. But smaller, lower end scanners have a smaller field of view, so you may need more dots with those. Now, the cool thing I think is that these markers can be on the surface. They can also just be like on the background. If you look at this picture here, let me see if I can zoom in. I think I hold control. There's actually some cards on the table here with dots on them. The scanner doesn't really pick up the black surfaces when you have it in reflective mode. So these don't really affect anything, but it's great. They're reusable. We just kind of drop them there, and you can see they're just cheap playing cards. But it makes the setup easier. You just drop a couple of these underneath, pick them up when you're done. Really nice. And the other thing you can see on here are these little magnetic marking balls. Now, not all props are magnetic or have the strongest magnetic elements in it, especially when you get into the stainless steel stuff. You can have non-magnetic stainless steel, but for the most part, you can get these markers to stay on there with, you see a little magnet on the bottom. And the nice thing is they've got a couple dots on them. So if you can see one of those markers, the scanner can track. Again, magnets make cleanup easy. We actually have a big magnet and we wave it over the little magnets and it just kind of picks them all up off the prop for us, which is great when you're scanning a 14-foot prop. Here's some other examples. The left here, this was a demo that we did down at New England Propeller. Doug Peck was nice enough to let us do some kind of scan demos on some larger props, stuff that we don't really have in our office, because we don't have cranes and crap like that to lift it. But yeah, you can see here this kind of the spacing on the markers. Another nice thing with this free scan scanner is it's got a single line laser mode. So if you have details like inside the bore here, this single line does a really good job at getting in deep holes. So that's just something, again, different scanners have different capabilities. We've tried to recommend the ones that are the most appropriate for what we're trying to do here. Over here, this is a little CPP wheel. A little depends on your definition, but for a CPP, it's kind of little. Yeah, instead of taking this off and breaking the blades down, we leave the blades all set up on the hub, and we put some magnetic markers on, scan the prop, and you'll notice that we got markers on 2 blades and we don't have any on the others. So what we'll do is we'll scan this blade and scan the hub, and then we'll just take the markers off and move them to the next blade and scan over there. So again, the versatility of those magnetic markers is super helpful. And you might think, oh, the scanner is going to capture these balls or whatever. Most of the time, the balls are black, so they don't get really captured by the scanner when you're in reflective mode. And the markers themselves are automatically deleted. So pretty much they get deleted automatically by the software. It's a nice. I don't think it was intentional, but it works out that way. Okay, we're getting through here. Again, one just the last thing on markers. Do not put them near the edges of the prop because again, the meshing software usually has an issue. You can see a bunch of holes in this prop, and then it's like, you get to this point and it's like, well, shoot, how do I fill in those holes? Essentially, you got to go back and kind of scan it again and fill it in. We can interpolate over them, but that brings me to the next point is don't put your markers on really tight curvature regions, because it will, where the marker is, it's going to look at the data around it and basically fill that hole. If you have a lot of curvature, you have more error generally when you fill it. So try and pick the flat areas. Don't put it, the fillet, I guess, is fine because it's not part of our inspection data, but don't put it on the cup, for instance. And again, this one says mark at least 3 markers. 4 is better, and spacing again depends on the size of the frame. So let's talk about what we need to set up for either TrueProp or PropCAD, or generally just making the data again useful. We really want to orient our propeller properly along the shaft axis. And if there's any sort of tilt or eccentricity or off axis error, what it will do is it will actually change the geometry of each blade. So we really want to make sure that we spend some time to get this lined up properly. And then, you may have a blade of interest that you want to put at, say, 12 o'clock on there. So when you do the scan, the very first frame you shoot becomes the coordinate system. And it's not like we sit above it. I mean, ideally, you'd shoot above it and shoot it perfectly down the axis. You can't do it visually. The other thing is, that the scanner camera doesn't shoot completely straight. It's really hard sometimes. So generally what you get is a output that's just kind of floating around in space. Like here's the coordinate system, and this is just like out there. And what we need to do to kind of begin to process the data is, again, line everything up along the bore of the propeller, the shaft axis, the same way that the propeller is going to rotate about when it's on the ship. We want to mimic that in the computer, for whatever we're going to do next, our next steps. So let me just zoom back out here. All right, we just got a couple more slides here. Cool video here on the left. This is another demo with Creaform. We're over at Accutech in Dover. Love going over there. They're right down the road from us. Larry's just a really smart guy. Great to work with, and grateful to have them nearby. So, in this situation here, the propeller's off the ship. It's sitting in the shop. We can scan it right there, and again, because there's no shaft or anything blocking us, we can actually get that bore of the prop itself. So that's the best situation. You actually capture the interior of the bore, and that gives you the features, the cylinder that we need to find that axis of rotation. The bore is obviously dictates how the propeller sits on the shaft, and so that's the best feature to use for alignment. And what we'll do is when we go to set this up, this construct cone fitting cone is kind of the command in Zeiss that's used to select that surface. A lot of that's done automatically. You click on the bore and it just fits the cone in there. We use a cone because it's a tapered hole most of the time. Okay, so let's look at the next case. Another case where the prop is actually in the shop. But this propeller, and this picture was taken down at Frank and Jimmy's during NMPA a couple years ago when we were in Fort Lauderdale. They actually did a demo of the 3D scanning and had the whole NMPA group there. Really cool to see. And what they did is they have a balancing arbor stand. So they use the arbor shafts or the dummy shaft, mount the prop on that, and then put it in the arbor, and that gives them a place to scan the prop. But the next, the nice thing about that is it gives you this big long shaft coming out of each end that you can use to fit a cylinder, and again capture that bore direction. So here you can use the construct cylinder, fitting cylinder, and you can grab the surface of this mandrel or dummy shaft or arbor, whatever you want to call it, and again, it's almost as good as using the bore itself. In fact, I think that that's probably even better than the bore itself because you get a long span that you can really get a confident regression in. So, when you show up to a job to begin scanning, you want to make sure, that you have some features for the alignment. And it kind of depends on, what's immediately upstream of the propeller. Definitely you want to scan the propeller. But you probably need to scan a little bit more than that to get the features you need to register because you're not going to have access to that bore. So you really kind of want to find some exposed shaft. And if you show up and there's a gap between, the strut barrel here and the propeller boss, you can get right in here and scan this. So that's nice because you scan the prop and then you just go upstream a little bit and you can pretty much stop there and you have that cylinder that you need for registration. Now, sometimes you'll show up and there's really no exposed shaft in between the hub and the barrel. And so in that case, you actually have to capture the strut barrel. And then, if you want to be diligent, what you should do, what I'm recommending you do is scan the shaft that comes out of the forward side of the barrel. Because the outer side of the barrel is cast, maybe ground, and then, it's machined, that bore is machined. So it's not guaranteed that those are concentric or perfectly circled. I'm talking about the barrel of the strut. So ideally you use the shaft. We know the shaft is a perfect cylinder. The propeller is riding through the shaft. It's not riding on the outside of the strut barrel. So So yeah, you may have to go and actually spend a little more time putting markers on this strut in order to go up here and capture enough of the shaft that you can properly orient your data after. Just a few more slides, and we'll get through here. So, and this slide right here is actually what triggered this entire presentation. Was I had a project with no exposed shaft, and this is the exact scan. And okay, what do I do to find the shaft axis? Well, there was some nuts on the scan, and those were captured. So it turns out that there is a way to fit a polygon, and you can actually fit a six-sided polygon to a propeller nut. It will give you the direction, the center and the direction. Um, and because of the way the nut is generally machined, you know, they're faced based on the bore of the nut, and they're faced true to it. So it's actually a good, uh, well, in this case, it's not the best, but it's a good uh, registration feature. So that's something new to try. I think probably no one has done that yet, even if you're a TrueProp user and you've been through our onboarding or our training. That's something you haven't seen before. So wanted to share that with you. And again, this is something I discovered, and then kind of I was like, oh, everyone needs to know about this. So here we are, giving you the goods. And so in the case that and these cases happen, if all else fails, you can use the outer hub surface to fit a cone or a cylinder. And there's cases like potted drives, tunnels, bow thrusters, where there's no exposed shaft to grab, or maybe there's a cap fin over it that you can't even see the nut or anything. So, I this is not ideal because again, material there's no this thing gets cast with a pilot bore, and then someone goes and shoots a bore through it, and there's really no while it should be perfectly centered in the hub, and the hub should be a nice cone. There's really no guarantee that it is, and so it's not an ideal surface. So one thing you may want to do when you do this is take a look at your sigma, your residuals, your max deviation. You can change the level of sigma, which will reduce the outliers. But sometimes you still just have to shoot registration through it, take a look at the output, maybe try it again, and just see uh, if there's a sensitivity to how you position it, your sigma level. Again, it's kind of a worst case scenario here. Your method of last resort. Um, so again, you're using the cone fitting or cylinder fitting here, and you may have to actually physically just like paint some of the surface here. In red, you can see basically the areas that I selected. So I use the end of the hub, and I use some data in between the fillets here, and I use that to regress my cone, which is shown in green. You can see it's coincident in some areas. It was okay. Forget if there's a report on this one. This was one that I had some doubts on initially, and so again, if you get into this scenario, what do? You basically have to go back and scan something again. So this kind of circles all back to like planning ahead. You show up there, and you really want to think about your objectives. Are you doing inspection? Are you doing reverse engineering? Are you doing a CAD design, a drawing? Does it have to be exactly correct? It should be. Um, Thinking about those objectives and thinking about how you have to do this registration step. Uh, just think about what you can use for registration ahead of time, and you won't get into a situation where you're like, oh shoot, I have to go back and scan more data because I have the propeller, but I don't have enough to continue. And so that's a lot of what I wanted to share with you guys today. Looks like we're running a little over on what I planned for time, but that's good. We still have at least 15, 20 minutes so for questions or whatever. And let's talk about just TrueProp, what our mission is again. So we're focused on propeller inspection software. Um, that includes digital data acquisition from pitchometers, manual entry of angle and drop data from like larger, older legacy devices to create kind of a quasi digital reporting system, and then this virtual data extraction from 3D laser scans. We do a lot of work uh, converting older pitchometer systems. We did one down in uh, New Orleans, down at Jefferson Propeller. It was a 120-inch pitchometer from Sound, just a manual. It had a little digital drop gauge on it, but we added encoders and converted that whole machine, so now it's a fully operating TrueProp system. And we do a lot of that kind of stuff and refreshing older devices, calibration, things like that. Do replacement software, obviously, you add TrueProp to it, and it's a new system. But we also do like hardware, helping people figure out what encoders or electronics they need. We offer electronics packages for people to basically build their own pitchometers. We just had uh, a customer up in Northumberland Propeller up in Nova Scotia, and Jerry there, he built his own frame, bought an electronics kit from us, has a fully operational digital pitchometer. Um, so that happens. And again, we do a lot of expertise in the electronic selection. Try to demystify the electronic side and let people take ownership of the frame, the table, the shaft arbors, all that kind of stuff, so they can modify as they see fit. And we'll just play some examples here, and then we'll get into the QA. So this is basically the steps. This is actually for the scan that we started with, that small propeller that I was standing in front of, the second slide there showing the scan. This is the data that came out of it, again with the prop nut on there that was used to orient it. And so the data is aligned to that axis. It's imported in, and what we're doing now is we're selecting kind of, what radial data do we want to take? Do we want to take, the 50, 70, 90? Do we want to take 95 through, 30 or 40? So we set that up, and, it spits out these blue lines, labels each prop, gets the maximum diameter of each blade. And then that goes right into basically the job management side. So this piece, TrueProp, is the main piece that can be used with either pitchometers, or it can be used with the 3D scanning data. So that scan comes in here, we get a preview, we get all of our bar graphs, our pitch readings. At the very bottom down there, you'll see the class tolerances. So it says it meets class 3 right now, and we're testing for class 2. And we're seeing a little bit of deviation at the tip there, and there it is on blade 4. Outline of the blades look good, they're all matching. The centerline rake profile is all matching, so the blades are sitting pretty well. And these are kind of individual scan lines from each radius, those blue lines that got overlaid. This is allowing us to compare blades 1 through 5 together. And again, here's that issue at the 95 there. The pitch is just a little too high. It's 30.7, and that segment should be about 29.8, anomaly 30. So it's almost an inch too high, just right there on blade 4. And you can also see maybe that blade 3. I'm looking over here, by the way. Blade 3 is also like, just right on the edge, a little low maybe. Looking at class 3 tolerances, everything looks great. So the prop, we can go and say, hey, this prop is class 3. This vessel is decommissioned. It was a research vessel from UNH, funded by grant money. Kind of an old repurposed vessel, and they got a new vessel, and they parked this one at Great Bay, and never serviced the propeller or anything, but it's got a nice 5-blade on it. And so we went out there and scanned it, and it was pretty cool. Nice project, nice case study, and yeah. So that's showing you just basically getting to the report. And I don't know how long that took us, maybe like two minutes or something. Most of that's flipping through all the screens, but that was all done in real time. So your scanning process, it takes what it takes. If you get good at it, it's like 20 minutes, maybe less. And pulling into TrueProp can be 5 minutes. Here we're looking at those pitch numbers that are out of spec for class one, and those would be areas that we would go and then repair. Basically, those are local pitches, and we got some section pitches. It's all on blades 3 and 4, kind of on the trailing edge and the tip there. Low and high things. Okay, let's see what else is next here. I'm gonna just try and force it to the next slide. There we go. There we go. This is that same prop being scanned here, and this is probably 3x speed or something like that. Then that's the end of the presentation, by the way. And you can see that I did capture, some of the strut upstream there. Um, I think I ended up blowing it away. I'll just go back here. I think I ended up blowing it away in the final, you know, mesh that I made before bringing it in. That's why I got into this situation with the prop nuts. So yeah, in hindsight, if I had planned ahead, I would have gone and scanned this shaft up here. It's a lesson learned, and then I want to share that all with you guys. So let me now, we'll wrap that up, and we will go to questions, answers, all that good stuff. And yeah, thank you everyone for attending. Looks like I got some questions here. Open. Kevin says 3 or 4 markers in view at all times. Yeah, or more. I mean, if it has more markers, it's not bad. But what will happen? You'll be waving around, and you'll go somewhere where there's no markers, and the scanner will start making some noise, like it's letting you know it like lost its position. Ours has some light feedback too as well, and some of them vibrate and stuff. Basically, tell you, hey, like you have lost tracking. It will stop taking data, or sometimes it will still take data but kind of buffer it until you go back to those markers. The nice thing about the magnetic markers is, and this happened to us on the 14-foot prop, you're scanning an area, there's not enough markers. Well, if they're magnetic markers, you could grab one and slide it where you need to go. So, highly recommend that. There's another question here from Araris. TrueProp only works with scans of Shining 3D, or it works with other scans. TrueProp is device independent, so it works with pretty much any scanner that you can get an STL mesh out of. So they make some scanners as low as like $800 or $900. Those tend to be just kind of like hobbyist toys. Um, Again, you'll have to use spray, you'll have to use markers, they'll have a small field of view, it'll take forever. The software's slow or buggy or whatever. That's kind of what you're facing with those really, the most cheapest affordable options. The Shining 3D stuff, they have one of those called a Star or Einstar, and that's probably where my inquiry actually first started. But it's really just not viable for props. I think that when you move up to like the Einscan HX, HX2, FreeScan, these ones are super capable. They make it easy, which is what I want to provide to our customers. I don't want to give them something that is really, really difficult to use. So that's our recommendation. Is kind of Shining 3D is a great product for the price, and it's kind of has all the capabilities that you need to make propeller scanning easy. It's not that you can't do it with more affordable scanners. You can. It's just, you might take more time and energy on your part. and also we can't really advise you on things. So we personally use the Shining 3D scanners, which is also makes it easier to train and give people advice. A lot of this information I gave today is really generally applicable to all laser handheld scanners. So, um, but yeah, that we originally started with Faro scanners, and then we're working a lot with Creaform scans, and it's only been the past like 3 4 years that we've kind of uh, been working with Shining 3D on developing this package with them. Rodrigo, thank you for the compliment there. I'm glad you enjoyed the presentation. Ignacio, thank you as well, my friend. Ignacio, I don't know if any of your pictures made it in here, but Pageant Swan was one of our first customers. We started a joint industry project with Wildcat, Argonaut, Pageant Swan, Linden Propeller. I may be forgetting somebody. Hopefully, they're not mad at me. Um, and that was where a lot of this, Wildcat was really driving the laser scanning initially, and they still use it all the time for their projects. So it started uh, down with those five companies, including and Ignacio and Pageant Swan. They do a lot of laser scanning now too, so they've grown into it and really been great at giving us pictures and sharing their experiences and stuff with us. So helps make the product better, helps make um, training and advice better. So big thank you to those guys. FJ Propeller, Accutech. These guys have all been featured here, kind of in this presentation. So big shout out to those guys for kind of their continued support and help. And any other questions here? Looks like I may have a couple more. Oh yeah, there's a bunch here. Um, yes. Okay. So the presentation, I think this has been recorded, so they will probably do maybe like an encore presentation later live, and then we'll have the video capture. We can send that out to anyone interested. So I'm not sure if it will go out automatically. If you're interested, just pop a note in here, and we'll make sure that we get a copy of the presentation for you. Thanks for the information. Very useful for scanning on site. Yeah, absolutely. You're welcome. I want to see more of it. Um, I'll be scanning a set of propellers this week. I will get uh, some data to you. Enjoyed the presentation. I would like a copy if you could say that. Yep, absolutely. Thank you. Anyone else who wants to ask questions? Now's the time. If anyone wants to be brave enough and step up on the video camera or the mic, I can. I have the power to give you some audio. Give you my soapbox for a bit. And I'll pop a question in here as well, um, which I get asked frequently. Let's see what else popped in here. Uh, yeah, at Ammonia we use Raptor X. Any issue reported with it? No, actually. So the Raptor X, most of our we have a couple users using Raptor X. It is a fairly affordable scanner. It's mostly geared towards the 3D printing community, but it is a blue light scanner. I think it's around like $1,500 to $2,000. So the only thing with the Raptor X, again, you got to use scan spray. The tracking can be tough, so you got to use a lot of markers. The field of view is small, so it may take a while to scan, a 40-inch prop. And it has some recommended volumetric accuracy, like it may only go up to like maximum 50 inches or something like that. But yeah, it's a great entry level scanner. I mean, it makes it extremely affordable to get into this. And I generally tell people to not buy the Cadillac as your first car, right? Like you can work up to this, and that's some of what we have. These two offerings. We offer the HX2, um, which is a great scanner. Uh, it's about $10,000 for that scanner. Um, it's really good. It, and it can do props. We had customers do props that are 120 inches with it. I think it's great up to props of about 60 inches. And then the free scan combo, it has just more laser lines. It's faster, um, so you need less markers, and you can scan much bigger stuff much quicker. And so if you're doing stuff in the 60 to 120, 160-inch range, that's the go-to solution. Now, if you have more budget, there's even higher end scanners. Creaform makes excellent scanners. Probably the uh, kind of known as kind of the best in the industry, and a lot of people are kind of following in their footsteps. But those scanners generally start at like 55 to $90,000, so you can buy a number of the Shining 3D scanners for that cost. So again, you kind of want to work your way up. You can always sell your old one and get a new an upgraded version. Um, so Raptor X, if you're curious about this type of tech, uh, it might be viable to just pick that up, start playing around with it, and then if you got some general engineering projects, and we can talk about doing propellers with it. But yeah, people are very successful with uh, Creality's Raptor X. I think it's Creality. Um, nice little product there. Um, and there's also some new stuff coming out with basically markerless scanners, where you have your scanner, and instead of putting markers on the prop, the scanner that you're holding in your hands has markers on it, and there's a tripod, camera that basically tracks where the scanner is. So instead of track the scanner tracking, the object markers, there's a second scanner tracking the first scanner, and that is really cool. The cost for that is coming down, where that'll be less than $75,000 for those systems. And I think as things move forward in the future, you'll probably see a lot more of those. It's a battle to the bottom on pricing. It's over the past 5-6 years, as more competitors come online, the technology becomes kind of more widely available, and so competition's good. It's good for us anyway, as consumers of this technology. Cool. Let me see what else we got here. Any other questions? Uh, yeah, it does work with Raptor X. Good. Um, yeah. So someone asked about drawings here, and if uh, you can go on YouTube and look up PropCad CAD import, um, or I'll send you a link. But it's a very similar process. In TrueProp, we extract. If I go back to this here, we extract data from all 5 blades. But if you want to make a drawing, you basically reduce it down to 1 blade, and the process is very similar. In fact, the tool looks very similar. It loads your geometry in. You select the radial positions of interest. It pulls the data out of the model, and it pulls it into PropCAD's design environment, which I'll just go back here and see if we can pull that up. So this is PropCAD's design environment. Again, here's those slices that get taken out of the model. Once you're in PropCAD, you have control over diameter, pitch. You have control over chord lengths, thicknesses, skew, blade area. You have control over all of the geometry in this tool, and you can edit it using propeller geometry numbers like pitch and camber and stuff. So, okay, you scan the blade, reduce it down to 1 blade of interest, select your radial positions and pull that in, and now you have it in PropCAD. PropCAD automatically creates this drawing from any propeller geometry that's in it. So The process is pretty easy. Scan, reduce to blade of interest, pull into PropCAD, and export your drawing. Most people are taking the time to kind of smooth out the data that gets pulled out, but that's it's all something that you can do in PropCAD. And again, if you search PropCAD CAD import utility on YouTube, you'll get a number of videos that show that workflow, and it's a very quick workflow, 2 minutes max from the STL to get to a parametric propeller design that you can export to SolidWorks or Rhino or Fusion, whatever you want to do. Um, so that's a great tool. What scanner would be best? So that depends on your budget. I think for a $10,000 budget, the HX2 is the best option. For the $16,000 budget, the free scan combo is the best option. And then if your budget can support more than that, there's a number of, you know, other options with larger views, different capabilities. The markerless one, the markerless one is about $60,000 right now. I think they are expecting a price increase on these scanners in June. So that's something to be aware of. But yeah, so it depends on your budget. My opinion is that these two, the HX2 and the free scan, are the best for the 10 and the $16,000 device budget market. Do we have a list of recommended scanners? Again, we recommend these two specifically, but we are not, we generally don't recommend one over the other. We just have experience with these. We own these ones ourselves and use them for our commercial work, so we can really help you out with them. Um, but yeah, there's a bunch of scanners. I have a cheap hobbyist one. It was maybe $1,200 or something like that. It's from RevoPoint. I've never even taken it out of the box to use it because I know it's going to be a headache, and that's generally what happens with the cheaper tools. Is they can get it done. Got to just fight through it, and like most things, you get what you pay for. You pay more for a more commercial metrology based solution. You'll be more. You'll spend less time on the project. You get better data. So it's one of those things. Again, there's nothing wrong with starting out with the Revo Point or the Creality, um, and Shining 3D also makes one you can look up called Einstar, EINSTAR. Again, about $1,000 for that. Great tools to really figure out if this is something for you or not. Um, you might outgrow them fairly quickly, um, especially if you're doing a bunch of these. And the other thing with those cheaper ones is the performance outdoors in sunlight is generally not as good, not as quite as many bells and whistles on the software side. Um, but again, a good thing to start. And our software does not care which scanner you use. Cool. Well, we are been on for an hour. If um, I think that's been really good, and good questions here, guys. And I appreciate everyone showing up, and happy to share with you guys. And please send us an email. I'm going to put my contacts back up here. If you guys have anything that, a lot of people don't want to ask their question publicly. They have some question that they want to ask us. Do it over email, measure@truepropsoftware.com. Okay, everybody. Thank you so much. Appreciate your time, and hope you guys learned something. Look forward to presenting again. Let us know what you want to see, and we will try to accommodate. Thanks. Just make sure I didn't miss any. Thank you guys. Yeah. Good to see everybody. And I don't actually know how to exit the meeting. Oh, and bye.